Okay, so this is a pretty interesting topic. There are some things I've learned from other tutorials that I will be sharing, but other things I've built myself. The goal of this workflow is effectively to be able to check the versions of Revit files without opening Revit. So the tool that I've developed based on a few other examples and also some customization is when you right click in a directory, you pick Revit version check. A little interface pops up and lets you pick any number of files from that directory. You hit open and a little message will tell you basically the files, and you can close the console before or after. This is a little Python package called Tkinter, but at the moment it's very raw, but I just wanted to share this as a technique because I think it's an interesting workflow in introducing Python to Windows through context. So I'm just going to OK this, and what I'm going to do is take out some of the steps that I've already set up to run this version of the tool, and we're going to build it roughly from the ground up. So I'm going to go into the registry editor. You can get here in Windows by going regedit. Now you're not necessarily going to be able to open this if you're not an administrator on your computer. This is somewhere you should only work with carefully, and usually you should have a rough understanding of what you're doing. A lot of this really dictates the behavior of your computer and Windows. So you have to be very careful. So at the moment, I'm just going to delete a registry key that I've created custom to suit this, and we'll come back to this just a little bit later. So I'm going to be using a IDE or an integrated developer environment. In this case, my chosen environment is PyCharm. I find it really easy to work with. I've done a little bit of configuration already in PyCharm, so I'll show you what I've done. So I believe under the file menu, under I think new project setup settings for new projects. First of all, I've had to make sure that my Python interpreter is specified. In this case, I'm specifying just this one here, get version. Now I can do Revit version demo. That might be safer in this case. But what you are going to have to do is make sure that you do have a very particular package installed. So under the install menu, I'm going to look for future, and this will basically allow us to work with single source support for Python 3 and 2. And it also gives us access to the package Tkinter, which is mainly why we're doing this, but it does also do a lot of other things. It shouldn't take very long to install, should let us know when it's finished. And this will be installed within the context of your IDE. So this won't necessarily mean it's available in Dynamo and other programs, but it is available to this particular environment that we're working in here. And we can see we now have future next to pip and setup tools and wheels. So I'm just going to OK this. And what that should have done is in the external libraries, it should have given us access to lots of things, including Tkinter, and the ability to utilize these in various versions of Python. So what I've done here is created a Python script. So I'm just going to delete, I might delete it. Yes, I'll delete it. All I've done here is just right clicked on my project, and I've created a new project originally, just saved it in a normal location. So I'm going to say new Python file, and you just want to call this whatever you want your tool to roughly be known as. So I'll just say, I might call this Revit version, Revit underscore version. At this point, we're basically in a position to begin coding, and I'm going to mostly focus on just building this tool to run on its own to begin with. We'll bring up the Python console so we can see what's happening when we run our tool, but we're going to be doing a few things. So we're going to be using Tkinter, which allows us to generate basic interfaces. So I'm going to import that. There's a few libraries we need. I'm firstly going to import OS, sys, and also stat, which we'll use a little bit later to deal with the read-only property of files. I'm also going to go from Tkinter. We're going to import a few things we're going to need. So in this case, the first thing we need is a file dialog class and also a message box class. And these will allow us to create basic interfaces. So now that we've done that, the first thing that we're going to want to do when we run our tool from the context of where we are is get the current Windows directory. So we're going to use the OS package for this. I'm going to say directory path as a variable is equal to os.getcwd, which will get the current directory from wherever you happen to be running your tool. And in this case, we are going to get context of the directory where we run our right-click command from. I'm now also going to go and get some file paths from that directory. So I'm going to say that file paths is going to be equal to the output of a Tkinter file dialog picker. So if you've used PyRevit or similar programs, the file dialog is a little bit like choose items from list, but in this case from a directory style interface. I haven't figured out yet how to create a dialog in right-click context that can work with selected files. So this is sort of my in-between approach for now. So I'm going to say file dialog, and I'm going to say ask open file name, which in this case asks to look at some files. There are lots of arguments we can specify here. I'm in this case just going to specify some basic arguments. So first of all, I'll say that we do want to do multiple files, which is an argument or an option. I'm then going to say file types, and I want to specify what types of files we can read. In this case, it takes a list of what we call tuples in Python, or pairs of objects in regular brackets in a list. So I'm going to start a list, and I'm just going to, in this case, probably specify 2 file types we can choose to look at. First of all, we'll do Revit families. So the first item in the tuple is what you'd like to call the extension, and the second one is actually the extension that you're searching for. I believe Tkinter automatically wildcards extensions on the front end, so we only have to say .rfa, not *.rfa. We can also specify a second tuple, so in this case we'll do Revit projects. And now the reason why we do want to limit the context of what we can pick is we are going to be reading these files in a very particular way that I've learned from Jeremy Tamek's blog, and if we did read a non-Revit file this way, it could potentially take a very long time and cause problems, but we're going to be reading Revit files instead. So after this, I also want to specify the initial directory argument, and I'm going to say that this is that directory path. So currently, the current Windows directory should be where this Python script is being run from. So if I hit play, I think we've got an error. I've got a bad argument specified in here. I think I've probably missed a bracket maybe. Just double checking which one I've got wrong. Initial directory, file types is a lowercase t. So lowercase t, hopefully that works. There we go. So we can see what happens is Tkinter does boot up this little sort of support window. I haven't figured out how to not make that show up yet, but I assume in Tkinter there's a way to do it, or you might be able to take advantage of building an interface into there. But for now, really, I'm just trying to get to an environment that looks like this. Inside my package or my project, I'm just going to make a test folder, and I'm just going to put some families in here so that they're really close to my testing environment. And we're going to want to, in this case, check their particular version, but you can see I can pick between RFA and RVT. So we effectively have created a interface to collect these files. So at this point, our script should be returning file paths unless we cancelled our Tkinter interface, and in which case we would want to just not proceed further in our script if file paths is equal to none. So what I'm going to do here is create a function, and now most of this function I've learned from a resource, in this case Jeremy Tamek's blog, The Building Coder. He does have a page where there's various ways of reading files in Python. I think this one he's written himself, and some other extra components were added. Now this is a pretty old file, it's from 2008, but I found that it still works, and it effectively looks through a Revit file using a very particular formatting in a Unicode build, and it looks for the keyword build : I think it's just the word build, because typically when being read in this particular way, the Revit file does actually have a key for the build of Revit that we can isolate. Now this could take a little bit longer on Revit projects because Revit projects are much bigger than family files in terms of character count and how long the file is. But in this case we will just work with this at the speed that it's going to run. So I'm going to define a function here. I'm going to say that we want to call this Revit version, and then we're going to take in a file path, and then we're going to use this later on in a loop structure. So I've been using functions a lot more in Python lately. I find it makes code really easy to read and understand. You can always look at these like custom nodes, and then you can put these into loop structures in order to apply what in Dynamo, for example, you might call lacing. So in this case, I'm going to say, first of all, that we need to open our file. So we're going to open our file path, and we're going to, in this case, open this in RB mode. Now I haven't actually checked what RB stands for, but I believe it's a safe reading mode, and I think it's reading in a binary way. So yes, a binary format. So in this case, it's looking at it, I believe, in a non-human readable way. It's quite an interesting argument. I've only found that I've used it in this particular workflow so far. So what we're going to do with that is we're going to get the data from that by using file.read in order to get the data out of that. And when we're done, we're going to do file.close. So this will attempt to read the contents. Now I found sometimes Python will put this file into a read-only state, but you can revert this back to a non-read-only state. So in this case, what I've found is I can use the OS library and I can use what's called chmod. Again, I'm not quite sure what that stands for, but let's check. So in this case, chmod is the change the mode of the path. So what we're going to be doing with it in this case is actually changing its state. So in this case, I'm going to specify first of all that we're working with the file path. And then we're going to be using that stat library that we've imported. And we're going to specify the iWrite property. So what this does, and I've just found this on Stack Overflow, I don't purely understand exactly how it works. It will take a file and remove the read-only flag from the file, just in case this particular script checked the file out, which I find sometimes happens, which means it can't be read by other functions afterwards. If you really aren't sure if this is always going to work, you can always put this into a try and accept, just to see if there are certain circumstances you couldn't apply that flag on the file for. We can just skip it. Okay, so now we actually want to look at the build. Most of this I've taken from the example with Jeremy's blog. So in this case, I'm going to be looking for build, and I'm using encode to the file as well, which will specify a certain way of reading the file. So we're using a UTF-16 LE format, and again, I don't quite know what that is, but we can probably very quickly see what that is. It's going to be a various encoding method for UTF, 16-bit Unicode transformation format. So I assume that this is related to the fact we're reading this in a binary structure as well. So I guess that's probably related to that. From here, I'm going to be finding the index where build occurs at, using find bracket s in data. And sorry, I need to do data.find. So this will return the index where the first occurrence of the word build is found within the contents of the file that we're reading, using that binary method. So assuming that we did actually find an index, we can say if I is greater than 0. So if I is effectively a number, otherwise we'll have I believe a -1 index if we don't find it. Then we can, in this case, actually find that string. So what I'm going to do here, and we'll have a look at this after, I'm going to just call this build string, and what we do now is say that data, it's equal to data, and we're going to slice the string as well. We're going to go from I, so the index that we found build at, and then we're also going to go to I plus the next 40 characters. I believe that's the number that is recommended. So I'll work with this for now. And then our function can return the build string, but I guess we're going to be in a binary sense here, so I guess we have to decode what we find. And then we're going to be decoding using the same Unicode format. So I think in this case that should get us back into a human readable version. And then if we didn't find the build string, we can return, in this case, I guess, a non-specified version of the build string. So the build string is going to look like build : space. It's then going to have 6 characters for the major build and 3 for the minor, I believe. So in this case, we'll just return all question marks for that particular string. So let's, for now, just try to print the build versions as they appear for each file. So I'm firstly going to say if, in this case, we can actually get these file paths. So if it's not none, then this should pass. I'm now going to just try to print the build of each file path. So I'm going to take this Revit version, and I'm going to say that we want to print Revit version for, actually want to say for FP and file paths. We're going to loop through each one. Then we'll try and print the version for each of those. I believe this should work. I'm just going to try running this particular script. Unexpected end of phrase. I think somewhere I've missed something. Line 27. Of course, missing bracket. So I'll run this. Tkinter boots up. We'll go to our test folder, open the family, and there we go. We can see that this is what the build is returning currently. And those first four digits there are the version of Revit that the file is. Now you can see this is very quick for family files. It's actually really efficient. You can technically run this from an environment like Dynamo as well, but often you're going to have to be in Revit to do that, and at which point you could probably verify the Revit file version anyway. What we're going to do with this is actually isolate the version string. Now I could build this back into my function and just get a different slice of the returned decoded string, but I'm just going to build this into my loop for clarity. So what I'm going to aim to do is output a simple message dialog with each line saying which file has which version for the user to see. So in this case, I've picked a fairly particular way to show this to the user. Again, I'll use Tkinter to show a simple user message a message box to the user. So I'm saying for file path in paths, so I'm going to go back a step. And I'm firstly going to get the name of the file. So to do this, I can actually take my file path and use the rsplit method to split from the right by a given character. And in this case, I'm going to split using the /. Sorry, I should say I think it is actually the / when I'm working in an IDE. Sometimes in Dynamo and Python, it will be the other type of slash I've found. But for now, we're just going to split once from the right at this slash, which should break out two strings. One is going to be the directory that the file is in, and the other one's going to be the name of the file. So I'm going to take the last object from the string, which should be the file name. So specify an index of -1 to get the last item from that list of strings. If I have a really long file name, I'm going to try and truncate that down a little bit. I've found in this case for Tkinter, it's good to truncate around about the 40th character. So I'm going to say if the length of the file name is greater than 40, then instead I'm going to say that file name is equal to file name. So I'm going to redeclare a variable using itself, but I'm going to use a slice. So I'm going to put a colon to 39. I think this takes 38 characters, I believe. From the object, and then I'm just going to add on the end a ... just to show that the file name is longer than what I would want to show, because it will go over the edge of the interface that I'll show to the user. And that should hopefully be enough characters for the user to understand the file in the context of its name. From here, I can go back and actually then go and get this Revit version. So I'm going to say ver or version is going to be equal to this function applied to FP. So now that I have this, I can build a message. And I'm going to say in this case, it's going to be the file name first of all, plus a space and a bracket, plus the version, plus a closed bracket. And then I can just append this to my list of messages. And then assuming I have a list of messages, I can now say my joined message is going to be effectively a new line using an escape character to indicate a return in Python. And I'm going to use the join method, and I'm going to be joining that list of messages. So this should create a single string where each name sits on a new line. Finally, using Tkinter, I'm going to make a message box. This is a special type of form, and you need to go show info for this one. Most of this I just learned through Stack Overflow, or just looking at the Tkinter docs, and also just looking at the type hints that came to me through just mucking around with PyCharm. So in this case, I'm going to say that the title of the format is Revit file formats, and we're going to be showing that joined message. So if I try running this now, there we go. Go to test, select my files, and we can see that we've generated a little message. Currently, I believe I'm just looking at the version. I don't believe I've sliced up that version at this point. So we could also slice the version. So in this case, we're going to be going from the 7th to the 11th character and slicing, I believe, in this case. So I could also take the outcome of my version check, which is down here. And what we might say in this case is we're slicing from 7 to 11. And now if I run that again, it should isolate those 4 characters and leave out the build. And there we go. We can see we've now got this instead. So I think it's a really cool little tool. Now the question is, how do we get this to run from the context of Windows? So there's a really great tutorial where I learned a way to do this using Python, then realized we can do this much more directly using the registry. But there is a really good tutorial that taught me about the registry by a channel called SedTech. It's not really a well-known channel, but it's a great tutorial called Add Python Script to Right-Click Menu in Windows 10. He shows how to use Python to actually write registry keys, which is probably a safer way of setting this up if a user doesn't know what they're doing. In my case, I'm going to just assume I know what I'm doing. So we're going to be, in this case, having to create a registry key and a registry subkey under a command. So this is going to be a fairly interesting step, actually. So I'm going to need to get a few file paths to make sure that I'm pointing to my project and also my Python script. So I'm just going to go to, I believe it's under users, my profile, and then it should be under pyCharm projects, Revit version demo. And I'm going to be trying to build a path out of 2 things here. So I'm going to have to write the string in a very particular way as well. So I've sort of got one that I've mocked up from before. So effectively the first thing we need to do is actually target the Python executable in our project folder. It just has to be an executor of Python that can run Python through the shell. So in this case, usually this is kept under, I believe, VENV. I don't know if that's environment variables. It might stand for something like that. Scripts python.exe. So I'm going to basically be building that path, but for my new project. So I've just changed the name of my project effectively. So we are going to target python.exe. You need a space, colon, and then you're going to be targeting, in this case, basically the same path, but you pretty much stop after your project. And instead we target our Python script. So Revit _version.py. Okay, so what do we actually do with these variables? Well, in this case, there's 2 things we need to do. So we are going to go back to our registry, and you're going to want to come to computer, hkey classes, root, directory, background, shell in this case, and we're going to go up to shell, and I'm going to right click on shell and make a new key. In this case, we can call this pretty much whatever we want. I'll just make this Revit version, just so it's really obvious what it is. You can even call it Revit version check. So in this case, we're going to firstly need to set a value here. So I'm going to modify, and in this case, you just want to do, in this case, the ampersand, I believe it is, and then also just the name as you want it to appear when you right click. So I'm going to say check Revit version. I might even do Revit versions because it's implied there's going to be more than one file. I now want to create a new subkey in here, and I'm going to call this subkey command. And this is where we want to put that path that is going to reference both the Python executable and also the script itself to run in the context of the directory that we're in. So I think at this point that should now hopefully work. If I right click, I should now see that check Revit versions tool. Let's go to a location where I know I've got some files, and I should see it run from that directory, and there it is. I can select the files and it will now run in this case. So I can actually, I believe I can close pyCharm altogether. So my Python editor doesn't even need to be present anymore. I can close my registry, can just pretty much get rid of everything. And I can run this on as many files as I want. Check Revit versions, and I can pick as many files as I like. I can toggle between projects and families. But we can see there I've got a really nice little summary of my files. I can always close this, but then Tkinter will also be closed, so that is one drawback of the workflow. There's probably cleaner ways to experience a user interface, but in this case I've just chosen to use Tkinter. I think I can minimize Tkinter and move this to the side so I can at least visually check these files. You could probably build this into a much cleaner output message as well. But just a really useful little utility, especially if you've got admin control over your computer, and it's certainly going to be a tool that will come in handy for me when I'm trying to constantly deal with incoming files, don't know the versions of them, and often people aren't telling me as well. So I hope it's been a really interesting tutorial, and again, I will put links in the description of the video to resources that helped me get to this point, but I hope this is a useful little example and shows you that you can run Python through Windows, which probably opens up some possibilities as well for developing some little utilities if you're familiar with Python, but maybe not so familiar with Windows PowerShell or custom application development.